This is still a concept, or this is still a topic that is related to internal flow, which is about pumps and gas and gas moving equipment. And when you're going to study this topic, you study it mainly from the slides because it's conceptual, and you don't have to worry about reading specific parts from the book about it. Okay, so let us start by this simple question. What is a pump? And what is the nearest pump to you? What's a pump? What is the nearest pump to you? So let's look at the answers for those questions. The first question is, what's a pump? So a pump is a device that transforms mechanical energy into fluid energy. So it will take the energy, the mechanical energy, and give it to the fluid, and is used to force liquids to desired flow rates, desired pressures, and desired elevation. So I am giving mechanical energy to the fluid so that I increase the flow rate or increase the pressure or increase the elevation. And the second part is, what's the nearest pump to you? It is your heart, where the blood is pumped for all of the parts of your body. This is the nearest pump to you. And let me go to the next slide. So there's another thing called compressor. So what is a compressor, and what is the nearest compressor to you? This is the second thing that we want to talk about, a compressor. So usually when you say pumps, then pumps are associated with liquids. We say we pump liquids. And devices that pump gases are called fans, blowers, or compressors. And this name the name depends on the pressure rise achieved. And if I ask you what is the nearest compressor to you, it should be your lungs, where when you inhale and exhale, you are taking the air, and then you take it to your lungs, and then let us say there is this compression, expansion and compression, where air is taken in and taken out. So the main topic of this lecture is to talk about pumps and the different types of pumps. In the next lecture, I'm going to concentrate on the gas moving equipment. So pumps for liquids, compressors for gases. So when talking about pumps, there are two major classes, and the question here is, what are they? What are the two major classes of pumps? Now, the two major classes of pumps are positive displacement, which is also called static pumps. This is the first type. And the second type, they are called kinetic or dynamic pumps. So we have positive displacement or static pumps and dynamic or kinetic pumps. Let us take them one by one. Okay, so let us discuss the positive displacement pumps first. Now, suppose you have such a pump. As you can see, this is called a piston cylinder pump, because this is the piston moving, and this is the cylinder, piston cylinder. So this is the piston and the cylinder. So what's the flow direction? As you can see, I have two cycles here. I have a compression cycle and I have a suction cycle, suction and compression. So the suction comes first, as you can see when this valve opens. So I have suction and compression. So the suction cycle, the fluid goes here. When the when the piston goes back. And then in the compression cycle, the fluid is going this way. So whenever I have suction, the fluid comes from down. Whenever I have compression, the fluid goes up. Okay? And you can see the movement of those valves. Whenever this is open, this one is closed, and vice versa. So what is the flow direction here? It is from down going to up. So this type, for example, this type, which is called piston cylinder, or also it is called reciprocating pump, the fluid is forced along by successive volume changes. As you can see, it is successive. It is one after the other. Okay? Or fluid displacements, as with the piston and cylinder. A flow from this type, is generally pulsating, مثل النبض. Okay, it is pulse after another. But because it is so fast, it's happening so fast, this pulse is not noticeable. So the first type of the positive displacement, it is called piston and cylinder, or it is called the reciprocating pump. Let me ask you again, what is the flow direction in this pump? Is it from up to down or from down to up? And if I want to answer this question, I will try to take my fluid from, let us say, from here, from down going up. Let us see if the fluid can do this. So if the fluid wants to go here, it can't, because as you can see, this gear will not allow it. If the fluid wants to go here, it can't, because the green gear will not allow it. And if the fluid is trying to go at the center, it can't, because the center is always closed in its, let us say, in its direction or its face. So let us try the fluid from from top to bottom. So if the fluid is trying to come here, yes, it can. It's going to be trapped and then going down. If the fluid is going to go there, yes, it can again, but it cannot go in between. So the flow direction then is from up to down. How? By trapping the fluid between the gears and the casing. This is called casing, and those are called gears. Okay, the fluid is trapped between the gears and the casing, and here in this pump, the fluid is flowing from up to down. So there is another type then, there's another type of the positive displacement or the static pumps, and this is called rotary pump. So the previous slide we talked about the piston cylinder or reciprocating. This is another type of the positive displacement, and it is called rotary pump. And in the rotary pump, the rotating elements, those are called the rotating elements or gears, fit the casings closely. And as they rotate in the opposite directions, the fluid is trapped in the space between the gear teeth and the casing, and is moved from the inlet to the outlet. This is what I discussed in the previous slide. As you can see, for example, here, the fluid is coming, trapped here, okay, and then taken out. This is the casing, and those are the gears. Here it is obvious that we have the flow direction from down to up. So the fluid is coming here, and then trapped here, and here, and here, and going up. So this is the second type of positive displacement. It is called rotary pump. Now, what was the second type that we talked about? We said there is the kinetic or dynamic pump. This is the second type. Let us talk about it now. So for the kinetic or dynamic pumps, there is one most common, which is called the centrifugal pump. The centrifugal pump. Another name for the centrifugal pump, also it is called the radial flow pump. Why it is called centrifugal pump? Because it uses the centrifugal force, let us say, to give this energy to the fluid. And why it is called radial flow pump? Because as you can see, let me introduce what's happening to you here. So this thing here at the center, it is called the eye of the pump, where the fluid comes to the pump. And once the fluid emerges from the eye, as you can see, let us trace this one. Okay, as you can see, it is going in the radial direction. So this is why it is called radial direction pump. It goes in the radial direction. So as you can see, it is coming from the eye, going in the radial direction, and then pushed out from the pump. So the rotating element is called impeller. So this element which rotates here is called impeller. The one in the previous one and the previous type, if you remember the rotary, it was called we call them the gears. And here I'm calling this the impeller. It is pushing, it is moving the fluid. The gears in the previous type, it was trapping the fluid. Here, no, the energy is coming from this impeller. And as the impeller rotates, water is thrown outwards or outward at right angles to its axis. So this is how the pump is working, the centrifugal or the radial flow pump. Okay, so for the kinetic or dynamic pump, the centrifugal or radial flow pump is the main one. For the positive displacement, we talked about the piston cylinder, and we talked about the rotary. So what are the characteristics of each type of pumps? I mean, why do we have different types, and what is special about each type? So for this type, what type is that? This is the piston cylinder or positive displacement. And what's the flow direction here? So as you can see, the flow direction is again from down to up. Okay, from down to up. So this is the first type. For the reciprocating or piston cylinder, usually it is expensive, it is high initial cost, and it is difficult and expensive to maintain. Why it is difficult and expensive to maintain? Because it has a lot of moving parts. As you can see, I have this shaft, I have the piston also. I mean, this piston is moving, I have those valves here. So this is why it is expensive to maintain and difficult. And usually it is used when high head pumping is required and operate at high efficiency. So at high efficiencies, at high pumping heads, we'll use this one as, let us say, preferable. And also it is more expensive, high initial cost, and difficult to maintain. The second type, which is this type here, is the rotary pump. Usually it is simpler to construct, easier to maintain because there isn't a lot of moving parts, and it is less expensive. And usually there are advantages when low pressure and low flow rates are needed. So for lower pressures, lower flow rates, this can be used, the rotary pump. And sometimes, or most of the time, it can be used for domestic water systems, for small water systems, not large ones. Now, this is the second type, which is the centrifugal pump. As you can see, the fluid comes here, and then once it comes from the eye, it gets thrown away by the centrifugal force. What is special about it? So for centrifugal pumps, usually they give satisfactory and economic surface, and they are better suited for dirty liquids than reciprocating or rotary pumps. Why is that? Why they are better suited for dirty liquids? Because in the previous two types, for example, if we go here, as you can see, you will be afraid of solids. If dirty liquids, they will contain solids, so you will be afraid of solids trapped here, and this will, let us say, cause problems for you in the pump. And the same thing applies if you are talking about this one, which is the piston cylinder, where you will have those valves, so you will get problems with, let us say, solids trapped here and causing problems to your pump. So this is why they are better suited for the dirty fluids or dirty liquids. Now, suppose I want to increase the pressure. Suppose I have two pumps and I want to connect them. And this connection, the purpose of this connection is to increase the pressure. So is it better to connect them, or is it right to connect them in series, or is it right to connect them in parallel? What do I mean by series and parallel? So I have, this is the fluid coming here to the first pump, and I have another pump. So shall I connect them like that if I want to increase the pressure? So suppose this is P1 and this is P2 and this is P3. So if I want to connect the pressure, if I want to increase the pressure, shall I connect them like this, or shall I connect them like this? I mean, this is the first pump and this is the second pump. So I take the fluid and like distribute it between the two pumps. So this is P1 and here I have this is P2. So if I want to increase the pressure, how to connect them? So the answer is I connect them in series like that. This is called in series if I want to double the pressure. And if I want to double the flow rate, then I connect them in parallel. So in this configuration, I'm not going to increase, let us say, the pressure, but I can increase the flow rate. But I'm not going to double the pressure. Yes, I'm going to increase the pressure, but I'm not going to double it. So pumps connected in series cause an increase in pressure, but no increase in discharge. As you can see, I have, for example, this is the first pump, will increase the pressure from here to there, and this is the second pump, where I'm going to increase the pressure from here, but now the discharge is not, it's not changing, it's fixed. Okay, sorry for that. And for the second case, the pressure, as you can see, that I'm getting from both pumps, I mean it is this thing here, and I'm not increasing it by connecting the two pumps in parallel, but this is what I am getting for the discharge Q. And here is if I have two pumps. So pumps connected in parallel will increase the discharge, but not the pressure, if the same pumps are connected in parallel. Okay, again, let me explain this. So this is the first pump and this is the second pump. This is called series, and the pressure here will increase, it will double. And this is the second configuration. The pressure here is not going to double, but I can double the flow rate. So here, double flow rate, and here double the pressure. Okay, so this ends this lecture, and in the next lecture I'm going to talk about the gas moving equipment, which are called compressors, fans, and blowers.